Welcome to the Walton Pi. Today we are going to be talking about function composition. So, function composition is one way that we are able to combine functions. Some other ways that we can combine functions is to add functions together, subtract a function from another function, multiply functions, or divide functions. So for example, if f of x is x squared and g of x is sine of x, we can combine these functions by saying that h of x is f of x plus g of x. So we could combine them by getting h of x is now x squared plus sine of x. That is one way we can combine functions. Another one is we could subtract functions. So one way is we could get x squared minus sine of x, or another one is we could have sine of x minus x. Both of these are still going to be functions. We could also multiply the two functions together to get a new function. H of x is x squared times sine of x, or we could divide one function from the other. So we'd either have x squared divided by sine of x, or sine of x divided by x squared. Note that when we divide, we are changing the domains. In each of these previous three examples, the domain didn't change. So adding, the domain is still all real numbers. Subtracting, the domain is all real numbers. Multiplying, the domain is all real numbers. But when we divide, we now have to include the condition that the domain is whenever the denominator function is not 0. So in our first h of x function, that domain is whenever sine of x is not going to be 0. And then for our second function, so h1 of x, that domain is whenever x squared is not 0. So that domain is all real numbers except 0. Function composition is a different way to combine functions. This is where we're going to change the input of one function to be the output of another function. So we take one function and we replace all the x's or the inputs of a different function with it. For example, f of g of x is one way to write f composed with g. So that is the official way that we would say this mathematically. Another way to write it is f circle g of x. That little circle is the composition symbol. So it's going to come up very frequently. Anytime you're talking about function transformations, those are one type of function composition. A lot of real-world examples have composed functions when you're modeling their behavior mathematically, and most functions that you're going to see are actually some form of function composition. So for example, let's say that f of x is x squared minus 2 and g of x is x plus 5. Let's go through and figure out what f of g of x is and what g of f of x is. Well, to start off, f of g of x, we are going to take whatever g of x is and replace the input of f of x with that. So we are really looking at f of x plus 5. So what we're then going to do is we are going to replace every x in f of x with an x plus 5. So that's going to be quantity x plus 5 squared. Since in f of x it's x squared, it's now going to be x plus 5 all squared minus 2. We can then expand that, so that becomes x squared plus 10x plus 25 minus 2, which simplifies to be x squared plus 10x plus 23. So that is one way to write f of g of x. Let's now look at what g of f of x is. So again, we're going to replace the x in g of x with the value of f of x. So that's going to be g of x squared minus 2. Well, plugging in x squared minus 2 for x gives us x squared minus 2 plus 5, which simplifies to be x squared plus 3. As you can see, the order of function composition matters. F of g of x is not usually equal to g of f of x. The order is going to matter. Otherwise, we might end up with very, very different functions. I hope this video was helpful and that you were able to understand function composition a little bit better. Check out some of my other videos on calculus, and please like and subscribe so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.